Hello guys. So last time we reached the point where we had all of the different categories. So we had the flush, we had the straight flush, we had our normal straight, we had our 4 of a kind, we had our 3 of a kind, we had our 2, a pair, and our second pair. Now, see, I renamed them so we can see them here. Now what we need to do is create a prioritization list, which basically is going to include whether something exists or not. So these are 1, 2, 3, 4, 5, 6, 7 of them. And I would like to first create an array. And let's go ahead and let's build the array normally and put these numbers into that array. So first I'd like to put in the straight flush that I have. Then I'd like to put in the 4 of a kind that I have. Then a full house, we do not have a full house in this category. So this is a straight, this is 4 of a kind. Full house at this point does not exist. The full house needs to be created. So I'm going to put that alone. We then move on to the flush, which is up here. We move on from the flush to the straight. Oh, I'd like these wires to be far. Then after the straight we have our 3 of a kind, which is right here. Then we have 2 pairs. A 2 pair can be easily identified by the second pair, and a 1 pair, which is basically just the first pair right here. And that is it. These are all the hands. The only hand that is not here is the full house, which is right here. And the full house will need to be implemented based on whether or not there's a 3 of a kind and a 2 pair. So for the time being, what I would like to do is actually to put it in as a -1. How about that? Can we put that as a -1 and then process it later? Or should we process it now? Well, we basically should just identify whether there is a full house or there is not a full house, right? So basically okay, let's leave it with a blank placeholder. Create a constant -1, which basically means it does not exist yet. So that's what I'm going to do with it for now. We shall come back and fix this later. I'm going to just put this in a tiny sequence. So this basically does not do anything except just say basically what this does is combine, right? Combine. No, I'm not sure what this does. I'm not gonna name it. It just combines them. Alright, moving on. Now let's start processing. So we can pretty much forget about this. What we will look for is if this is equal to 0 or not, or should we first process the full house? So first we combine them. How about we combine them and process the full house? Yeah, I like that. That sounds like a good idea. Let's go ahead and do that. So this combines them, but I would also like to take a 1 pair and a 3 of a kind. So if this is not equal to 0, if this one right here is a 3 of a kind, this is not equal to 0, and the other one obviously is not equal to 0. So if these two and these two here are our 3 of a kind and our 2 of a kind. So if these two, both of them, are not 0, then we can just easily convert this into a Boolean, which says, okay, so if they're both not 0, if this and this, make sure this is an AND, yes, that is an AND, is not 0, then it's true, and if it is true, that means you have a 3 of a kind. Otherwise, you do not have a 3 of a kind. Pretty straightforward, very simple. And there it is. So this does arraying. Right? That's what it does. So this is arraying. And locate full house. So this does two things. So I'm gonna put the arraying on the bottom, locates, so this locates a full house and basically arrays everything. Pretty cool, pretty cool. So now that we have this, we can move on. Let's move on. And the way I want to move on is a simple, is this equal to 0? And create an indicator of that. This will give me a multi-line that tells me, basically, there we go, yes or no. Now, there is a small, tricky thing going on here, which needs to be addressed. Basically, there should be a form of superseding. Basically, the first true, the first false in this case, should be accepted. So is this replace comparison not equal to 0? The first one that is not equal to 0. So what we're going to do is we're going to do an array. We are going to search the 1D array, search this 1D array for the element. The first one that is not equal to 0 is obviously, so let's do this. First one not equal to 0 is going to be the winner, and this is the index. And now we're going to have to index to get 1, 2, 3, 4, 5, 6, 7, or 8. Which one of these is our winner? Which one of these does this belong to? Let's see, how do we want to do this in a way that is very conservative, non-lethal? We have this small problem where full house, for example, requires 2 numbers. A full house is going to have a high of 2 numbers. The 2 pair is going to have 2 numbers, and so on and so forth. So we're going to have to figure out each one individually. But we actually only need to analyze the winner. So the winner, index the initial array based on index that element. From this list, index that element. So if it is a straight flush, so if we're going to have to do this for every single one, if it is equal to 0, this is a straight flush, then we will need to know, basically, a straight flush is treated as a normal straight. So we need to figure out the straight. So this is going to be our 0. Should have done that. 1. Oh. Let's see. Ting ting. 1 space space. Let me do that and get back to you. Alright, so what I'm going to do, just realized a good idea would be to create a case structure that will accommodate to all of those 7 situations based on the number that we get, with the default being an 8th system. So there's 0, let's see, there's 0, 1, add case, oh, 1, let's see, delete this case, 0, no, 0, add case, 0, 1, 2, 3, 4, 5, 6, 7, 8. So these are the 8 numbers. To determine the high card, what we need to do is probably add a default here, which I did not calculate a high card because I just did not care. Array 8, after flattening, should give us a high card. So after flattening the 8 here, let's go ahead and get a high card. What I would like to do is I would like to create a for loop. No, I don't need a for loop. I would like to create a search the 1D array, search this array for the element 1. When it finds it, this index of the element. If this is, let's see, if this is less than 0, if this index is less than 0, then or let's see, if this is greater or equal to 0. Is it greater or equal to 0? True or false? Just like we did every single time before. Just give it to me and call it there we go. And this is our 8th case, not included yet. Right here, add the 8th. The 8th case is our high card, which is the default system reply, if you will, to whatever, well, whatever you want to call it. One sec, let me arrange these and come back. Alright, so there we go. I added it, I put it in here for now. We'll go ahead and arrange everything later. So coming back here, there we go. We have from 0 to 7, and then we have our 8th, which is going to be the default, and the 8th is our high card. So this is the default scenario. Just in case nothing is on, then the high card will be on. And the only reason I added a block out of it is because I need to have a number for it, and the high card will always be true. If nothing else is true, the high card is true. It might not be a winner, but it will be true. So now that we have this, we're going to have to do the analysis for every single point independently. Well, almost independently. So 0 is a straight flush. If we look at our settings, a straight flush, they will have a high number. And this high number, we can we determine it directly from it? Seems like we can. That is perfect. So we can just index this array wherever this is. In this case, we index it at 0, and this is the element that's going to come out of here. Now, for a 4 of a kind, also it is pretty straightforward. Same thing as what we just did here. So for a 4 of a kind, we take it in with the index, and that's it for a 4 of a kind. A full house. Now, a full house is trouble. A full house, we are going to have to take in our array, and we're going to have to get the 3 of a kind and the first pair. So we're going to have to get number 5 and number 7. Create constant. We're going to need number 5, and create another constant. We're going to need the number 7. So there we go. The number 5 and the number 7 give us the 5 is the 3 of a kind, the bigger one. Number 7 is the first pair, the only things we care about. Number 3 is a flush. Now the flush has no value. It gives us the type of the flush, but we do not care. A flush is a flush, but a flush, let's see our flush analysis box. Flush analysis. The flush will give us a 0 or tell us where it is. Now, if we do have a flush, the number I would like to get out of that flush is where that flush is. So I'd like to expand this so that the flush will give me the... I just remembered, guys. The reason we did all this work back here was to isolate the hand combos from everything else. Now that we have, this is where we're gonna need it to create the flush. So let's go ahead and try to fix this. So basically the flush will be based on whether you are using your hand or someone else's hand. Sounds weird, but that's exactly what happens. So let me get that from over here. There we go. And here we're going to have a subarray of those two numbers. And based on what the flush is, we're going to have to get that number into the system. So I'm going to move this, and I'm going to try to make this bigger in efforts to create enough space to figure this out. So we're going to have to get in the two numbers from this array. We get those numbers. Those numbers are going to come in unindexed. We're going to index them. There's only two of them, right? Yes, there's only two of them. Let's create an indicator just to make sure. Oh, we have an error. Interesting. Okay, then let's just give it... no. Just give it any number for now. And let me just make sure that this is going to give us two numbers, 404, 402 in this case, 404, 402. Perfect. So these are the numbers coming in from the hand. And these numbers, in the event of having a flush, we need to figure out if these numbers actually have a flush in them or not. So what we need to do is perform an expression, which is to take those and do an x over 100. Now an x divided by 100 is going to give us the value, which is I plus 1 in our case. Now, if, let's set up a system that says equal. This is equal to this. Create an indicator. This indicator will indicate, oh, another error. Again, get disconnected to 0 for now. Let's run this. We got two matches because they're 404 and 402. They are both 4s. There isn't a flush of 4 though, but it doesn't matter. Point is that those two must match wherever we are. So those two match the 4 in this case. Let's go ahead and get us a flush on 4. There we go. And let's change that to something so we don't have any errors. Let's run it. Now, 1, 2, 3, 4, 5. What's wrong? System should... oh, it's not detecting flush because the flush is over here. Huh. Okay. So it is technically detecting a flush. So this flush here if it is equal to this, and this should be equal in 1, 2, 3, 4, 0, 1, 2, 3. So there is a flush. This flush is a flush of spades. Spades are 4s. So this is not actually just I plus 1. This should actually be a 4 minus x. Now, show me. Perfect. They are both equal. Now, if we do, first of all, we do in OR. If any of these is true, then we perform the above task. Otherwise, set it to 0. Otherwise, we set this to 0. Perfect. Straightforward, understandable so far. Now, let's make this bigger, get ourselves some even more room to work. A lot more things going on here now. So, if they are equal, if either of these are equal, perfect, send them through, otherwise send a 0. Now, when we want to send them through, we want to figure out which one is bigger, literally. And to do that, what I am going to do is I'm going to take the numbers and perform the subtraction to them so that we can figure out what their sub numbers are. So, what are their sub numbers? So this is x divided by 100. That gives us another number, and now if we subtract the original number from x times 100, that will leave us with a small 2-digit number, which should be the 2 digits that we care about. Show error, this has nothing, set it to 0, and run. 4 and 2. Perfect. Now we just need to take this, get the array max min, and basically just send through the maximum value. And that is it. We are done. Last thing to do is the, I will say, ever so famous organization. Let me do that and I will be right back. Actually, no, let us do a check. Does this actually give me a 4? Yes, it does. Yes, it does. Now, a 4 is an actual number 4, so that's fine. Let me arrange this. So there we go. The flush has been adjusted and compressed, so now we have a much better flush analysis with the highest number. So the flush is going to actually give us the highest number of that flush. Perfect. Next thing is the straight, and the straight again just gives us itself. The 3 of a kind gives us itself. These all have no problem whatsoever. The 2 pair will need to give us itself, as well as the 1 pair. So the 2 pair is going to have to give us itself, as well as the 1 pair. And there we go. That's itself and the 1 pair. Finally, 7, the 1 pair just gives us itself. It's just like all the rest. And the high card gives us itself. So in essence, everybody's just giving you yourself, isn't there? Let's see, 0, 1, 2 is special. 3, 4, 5, 6 is special. 7 and 8. So the only ones that are special are the full house and the 2 pair. So the better thing to do is, if to run these checks, if this is equal to 2, and then create a true or false, else, basically if it's equal to six, so if it's equal to 6, actually should probably be the lowest one, or should it be the highest one? It doesn't matter, does it? It's equal to 2, it's going to do that. It's equal to 6, it's going to do that. And if it is equal to there, let's just do it this way. So if it's equal to 6, it'll just do what the 6 is. If it's equal to 2, just do what the 2 is. Otherwise, it will just do what I tell it to. Right? Right. So in the event of a 2, it will do this. Take in the numbers 5 and 7 only. Let's go ahead and build an array out of those. And send that through. In the event of a anything else, just a 1 number array with that value in mind of original array, and send that through. And if we have a 6, we do this little magic trick here, from this to that, nope, to the array, I'm sorry, let's get the array from down here for now, build an array out of that. Okay, let me clean this up and get back to you guys. This should give us here an array of the winning system. So let's see, what do we have here that is winning? In the current system, we have 4. 4 represents the flush. So let's just destroy that and see what do we get. If it's not a flush, we have a 2, which in this case is a 3 of a kind. Perfect. What if I get another 4? And run. Now I have run, should get a full house built up. I have 3 of a kind and a pair. 3 of a kind. 2 is a 3 of a kind. A pair, and 2 is a pair. 3 and 2. 3. Oh. There we go. Run it. Yes. 3 of a kind and a pair. We have a full house of 2 and 4. Alright guys. So this works, and I will see you guys next time.